Started.
Hello, I'm Reaney, and welcome to my Constant Velocity Lab Report. Students will record a video of the motion of some object that is moving at constant velocity. Using Tracker, these students will track its position versus time. Students will then use this data to create a computational model in GlowScript, which will display Newton's second law of motion. This model should include both the observed and predicted motion of the object. Through observing the motion of an object with constant velocity, Newton's second law and the momentum principle should be exemplified. This is since there is ideally no net force being exerted on the object to affect its velocity in the x direction. We'll see that this only really works in a vacuum, and when you assume that the system does not include anything else, and that is not the case in the real world. Results: the model of the observed position versus time of the object is pretty similar to the prediction model. However, there are some minor differences, which can be due to human error when analyzing the position and friction or other forces acting on the object. You can see the experimental position, the change of position was the orange, and it ends up being farther than the predicted position, which is a straight line, assuming there's no force, which yields a constant slope. Now, I was recording from left to right on the x-axis. If the object was moving from right to left, this may be inverted. If this was quadrant 1 of a graph, it'd be quadrant 4, and same direction. And here is my video. I used a elongated tube, a Warheads 2, that I found. Chose to use that. After performing the experiment, I tracked the location in front of the object 70 times with a camera that was 30 frames per second, which led to the data shown on the graph. I chose the front because it was pretty difficult to get the center of mass, especially when, if you saw in the video, it kind of changes the viewpoint of the can. It's not always dead on. While the graph is generally linear, there are some bumps which are most likely due to human error of me tracking its motion and potentially outside forces. On top of that, the velocity towards the end of the graph seems to tail off a little bit, which could be due to the object slowing down due to some outside force like friction. Or this could also be due to, as stated earlier, human error in my tracking, especially with it being a little bit more angled in the video. The coding. I took some of the starter code provided and changed some of the initial positions. This helped create a prediction model of the object's position versus time, as shown here. I calculated the position vector from the initial position as recorded in Tracker, and the velocity, I used this formula up here, where I chose the first two positions of the object, subtracted, found the difference, and divided that by the change in time of the first two objects, which led to 0.245, as shown here. Delta T 0.032, as that was roughly the frame rate of my camera, and it took 2.3 seconds. The F-net vector is 0 under the prediction because we assume there's no net force, and I used the velocity update formula, or using the momentum principle, to say the change in velocity was equal to the net force on the divided by the mass of the ball times change in time. Now, since the net force is assumed to be 0, the velocity should remain constant, as seen by the constant slope. Now, I used the position update formula to calculate the change in position of the ball, or in this case, the elongated tube, and I used the velocity times time and add that to the previous position, which led to this graph here. Now, it is difficult to state the pushes and pulls on the object. There could be some drag or friction. Friction would push it back. Now, there is a chance that the table that this was located on is slanted either backwards or forwards. And if in the case, since it did seem to go farther than predicted, the table might be slanted in favor of its motion, and the x component of gravity pulling down could have helped push it a little bit forward during the motion. That is it for my lab report. I hope you enjoyed it, and thank you.